Today we will talk about scientific notation and why it is so important. Today's objectives are convert between scientific and standard notations, use scientific notation in multiplication and division, use scientific notation in approximating and estimating. The question is, why do we use the scientific notation? The scientific notation works as abbreviation, as a short way to write numbers that are really big or really small. In math and science, we are spending a lot of time dealing with huge or very small numbers. Just take a look at all those zeros and imagine how will you multiply or divide those numbers. Let's define the scientific notation. A number expressed in form a multiplied by 10 to the power of n, where a is greater than or equal to 1 and less than 10, and n is an integer. For example, the temperature near Sun center is 20 million degrees in Kelvin. The number 20 million is written in standard notation. The equivalent of the same number in scientific notation is 2.0 multiplied by 10 to the power of 7. How do you write a number in scientific notation? Let's consider an example, 20 million. Here, what we do to compress this big number, we have to figure out where the decimal place will be. A lot of big numbers will not have a decimal point, but you should know that you can always locate the decimal point right after the last digit of the whole number. You will move the decimal point to the left until the number in front of it is between 1 and 9. So, 20 million in standard form will be written as 2.0 multiplied by 10 to the power of 7 in scientific notation. Now let's consider very small number, 66 millionth. You will move the decimal point to the right until the number to the left of it is between 1 and 9. So, very small number, 66 millionth, in standard form will be written as 6.6 multiplied by 10 to the power of negative 5 in the form of the scientific notation. Please notice that the exponent is negative. Now we have different tasks. How can we change numbers in scientific notation to the standard form? We have to decide in what direction will we move the decimal point. If we are working with negative exponents, we'll move the point to the left. If we will work with positive exponents, we will move the decimal point to the right. Example. Let's write 7 and 893 thousandths by 10 to the power of positive 5 in standard form. 5 is positive exponent, so we will move the decimal point 5 decimal places to the right and receive whole number 789,300 in standard form. Now, let's take a look at the problem 4 times 10 to the 4th power plus 9 times 10 to the 4th power. Please remember that you can add or subtract if the bases have exactly the same exponents. In our case, both bases of 10 have an exponent 4. So first we will add 4 and 9, then we'll multiply the result by 10 to the 4th power. The answer is 13 multiplied by 10 to the power of 4. Subtraction problem will work the same way. You will subtract first numbers first, and then multiply the result by 10 to the fourth power, in this case as well. So your answer is 6 times 10 to the power 4. Please notice, if bases of 10 in the problem have different exponents, your goal is to rewrite the problem using bases of 10 with exactly the same exponents. The multiplication problem, 7 times 10 squared multiplied by 4 times 10 to the power 5, you will multiply the first numbers 7 and 4 first, and then multiply bases of 10. Please remember to use product of like bases rule. To multiply powers with the same base, add the exponents and keep the common base. So the product of 10 squared and 10 to the fifth power equals to 10 to the power of 7. The product of 7 and 4 is 28. So to finish the problem, we have to rewrite 28 in scientific notation as 2.8 times 10 to the power of 1. And please don't forget about 10 to the 7th power. So the final result of our problem is 2.8 times 10 to the power of 8. Let's consider the division problem. 8.4 times 10 to the power of negative 5 divided by 2 times 10 to the power of negative 8. You will divide the first numbers 8.4 and 2 first, and then divide the bases of 10. Please remember to use quotient of like bases rule. To divide powers with the same base, subtract the exponents and keep the common base. So the quotient of 10 to the power of negative 5 and 10 to the power of negative 8 equals to 10 to the power of 3. The quotient of 8.4 and 2 equals to 4.2. So the final result is 4.2 times 10 to the power of 3.